Let's talk about the very frequently asked interview question by the interviewer for ML or data science position. What is feature selection technique and what is feature selection? Okay, first of all, we'll discuss about why to go for feature selection. Why not use all the features or all the columns for modeling? So the answer is if you all the models for feature for modeling, then there will be chances for overfitting. Secondly, the training of the model will take more time. Indirectly, it means the computation power we require will be very high, or it will be too much, and the model will be very complex if you use all the feature. And the other side, the merit will be yes, it will be a simple, easy to understand model, and the training will be it will take less time to train the model, and obviously it will reduce the overfitting. So we'll get a proper model to predict. All right. So there is various type of feature selection technique. We divide it into three part or four part we can say. First one is filter method, where you use all the statistical techniques, all the statistical test, and it usually happens before the modeling. We select the feature, then we send the feature for modeling. Second is the wrapper method. What is used to happen is like we train the model repeatedly to get better result. I mean to get better feature. Then third one is called wrapper method. What used to happen in the wrapper method is during the model training, the model will automatically select the best feature. So let's understand all the types of feature selection. Let's jump into my notepad.
Feature selection and what are the benefits of doing feature selection. So now we'll talk about the what are the different kinds of different types of feature selection technique. First we'll talk about, as we talk about, there is filter method, wrapper method, and embedded method. We'll talk about filter method first. So in filter method we basically use statistical tests, tests like chi-square test, ANOVA test, and Pearson correlation. In chi-square test, where can you use chi-square test, where our feature will be categorical and our target will be, and the target will be a classification, means categorical. Then when to use ANOVA test, where our feature is numerical and our target is classification, I mean categorical as well. Okay, so what about feature correlation? We can use feature selection. Well, our features will be numerical and our target will be regression. Now let's talk about the wrapper method. What happens in wrapper method? So what happens in wrapper method is we train the model repeatedly. What do you mean by repeatedly here? Means like we kind of do experiment with the model. The model will itself will do experiment within itself. Now we have three techniques inside it. One is forward selection, second one is backward elimination, and third one is RFE techniques. Okay, so what happens in forward selection? If you go for forward selection, then we'll start with zero features and we gradually adding the feature one by one. Let's suppose we have features like A, B, C, D, E, F. Now targeted column is G. Now we'll first start with A, then we'll again in the next iteration we'll go for A and B, and then train the model. Then the next one we'll again add on the third one, A, B, C. Then we'll keep on going. This is called forward. That is what happens in forward selection. Now what happens in backward selection elimination is, now we'll rank the feature and we will take all the features first and we'll do modeling, we'll do training, and then we remove the unnecessary feature from it. How? Based on p value. Now we will talk about the p value. P value is probability. Now the one which gives us less probability, that it will add on some correlation for the I mean which will contribute. I mean what we want is the model should, the features should contribute something for the model to get it trained. I mean to make it a good model. So that is what used to happen in backward elimination. What will happen is like we'll take all the features and based on p value, then we'll gradually remove one by one which are unnecessary. And the same thing happens in RFE as well. But the thing is, RFE, if you use RFE, there will be a feature imponence library will be there, and we'll use it and then we'll rank it, which all feature will be required and which all won't be which all are not necessary. So we'll remove the unnecessary and we'll add only the required one. That is what all about a wrapper method. Now we'll talk about embedded method. Now embedded method is something like it happens during the model training itself. like okay, we do not have to select anything, or model do not have to select anything before training. So during the modeling only, the model will get to know, okay, these are the features which can contribute, and these are the features which are useless. So there is something called lasso, and there is something called reach. Also lasso is known as L1 regularization, and reach is known as L2 regularization. So these two are kind of regularization technique. We will talk about regularization technique in upcoming videos. And there is something called feature importance. So in random forest, decision tree, XGBoost, light BGM, okay, so these model have a within I mean they have a built-in feature. There's something called feature importance library, whom we can use, and we'll get to know, okay, what is the contribution of A, what percentage of I mean how much contribution A has provided, how much contribution B has provided. Let's suppose, I mean, we'll take the same example. Our G is the target set, and we have features like A, B, C, D, E. Now it will give us the contribution in percentage. Now like A has given 20%, B has given 30%, C has given only 2%, and D has given 40%. Now obviously we're gonna take, I mean, majoritarily we'll select the D, B, and A, and we won't select the C. So that is what happens in embedded method in features importance technique.